Today's video is about stoichiometry and more specifically about stoichiometry done the BCA way versus dimensional analysis. So in this first example, we are looking for grams of methane or carbon tetrahydride, and we have 4 moles of carbon. So with the BCA method, we start with our before. We have 4 moles of carbon, and we are looking for methane. Unlike when we were doing a limiting reactant problem, we are not given the amount of water and we don't really care about carbon dioxide in this question. So it's going to make our lives a little bit easier. So in our change column, we're going to use all of the 4 moles of carbon and we're going to make a certain amount of methane. So you know that we go ahead and make it positive on the product side because we're now creating it. And then we're going to use the ratio, the mole ratio, from the coefficients in front. So the 2 comes from the 2 in front of carbon in the reaction. And we have a 1 for the 1 in front of carbon tetrahydride in this on the product side. So again, we don't need to worry about water. We don't need to worry about carbon dioxide in this question. So when we go ahead and do our after, it's a quick, easy one step. This is going to be 0 because we used it all up. 4 divided by 2, because 4 times 1 is 4, divided by 2 is going to make us 2 moles of CH4. Now, it did ask for grams, so I do need to take a step further. So 2 moles of CH4, and I need to go ahead and use a conversion. 1 mole of CH4, and this is my molar mass. Molar mass is 1605 grams. Again, this is my conversion here. So we have to go ahead and actually solve for what we're looking for. When I multiply the 2, I get 32.10 grams of methane. Now, this is the BCA method that we have learned previously. There is another option. It is called dimensional analysis. So instead of making this table, we can look at this reaction here and we're exact same question here. We're going to start with the number given to us in the problem. So you're going to start with the 4 moles of carbon. But what is different is now we got to put the mole ratio in the dimensional analysis grid itself. So because we're in carbon right here, we're going to put carbon down there. You must include the substance formula. If you don't, you get it wrong. You also must include the units. That is what's different between BCA and dimensional analysis, is here we are canceling the unit and we are also canceling the compound. Then right next to it, we're going to put the 2. The 2 comes from the reaction. And we're going to go to wherever we're going, which is methane. So 1 mole of CH4. Again, you must include the unit. You must include the compound. So this is the 1 comes from the methane in the reaction. But we're not looking for moles. Remember, we're looking for grams. So we have an extra step. So this does save a little bit of time. And we're going to put our molar mass on top because we're looking for grams. So this is a conversion to the unit we want. This is our mole ratio from our reaction. And this right here is the number from the question. So when we solve, we're going to take 4 times 1605 and we're going to divide it by 2. So again, it's going to be 4 times 16.05 divided by 2. And your answer should again be 32.10 grams of methane. This was the first example on dimensional analysis versus BCA. Watch the next video choosing a different question.